All right, welcome to Unit 10, Learning Target. I can graph quadratic, should be quadratic functions, but quadratics. Parabola. So the first thing we need to talk about is the U shape made by quadratic functions. Okay, I have an example of one right to the side here. So before I talk about how to graph it, I want to make sure we understand some really important information on this graph. So first off, I can see the x-intercepts. So remember, the x-intercepts are made on the x-axis. Here's the y-axis. So the x-intercepts here look like we have x equals 1 and x equals 3. Okay, so that's the solutions. Our x-intercepts are then 1, 0 and 3, 0. Okay, so they're where y was equal to 0, if we set it equal to 0. The other thing we have is the line of symmetry. So right down the middle there, oftentimes it's abbreviated LOS, but I'm going to write line of symmetry. Oops, symmetry. Okay, LOS. Okay, we can see where this goes through. It goes through this line, which is x equals 2. Okay, on this graph, I can see there's a minimum, so there's like a lowest point. So the vertex, right there in the green, that is a minimum. Min equals, and we can see that point looks like it's 2, -1. Okay, I can also see that there is a y-intercept. Y-intercept. And that point is 0, 3. Okay, and that's where x equals 0. Okay, so now I want to show you what the equation to this graph was and kind of figure out how to get some of this information from that equation. Okay, so that equation is y equals x squared minus 4x plus 3. Okay, so looking at some of this information, ways to get the line of symmetry. Okay, and then we'll come back to this picture, but I want to take a look at it. Look back at that. There's that vertex, 2, oh, that's hard to see, 2, -1, right down there. The line of symmetry goes through that 2. Okay, let's look at a couple other things, the y-intercept and the x-intercepts. Okay, so going back, y equals x squared minus 4x plus 3. Okay, so the line of symmetry can be found by -b over 2a. So you might be thinking about those letters. What do those mean? Okay, remember, a is the number in front of the x squared. So in this equation, a equals 1. We've had a lot of talk about that. In this equation, b equals -4 and c equals 3. All right, so we're going to plug in. Okay, so this says -b. If b is -4, we want the opposite of that. So I'm going to put 4 over 2 times, what's our a value? Well, 1. All right, so 4 over 2 times 1 is 2, which is 2. So our line of symmetry is x equals 2, which we saw on the previous graph, and we can go back to. Then, if we know that for the vertex. Okay, so we look at this. A equals 1. That's a positive number. So we know our vertex is a minimum. Okay, because A is positive. So we take our x equals and we plug it into the equation wherever x appears. So we'd write y equals x squared. All right, so 2 squared minus 4 times 2 plus 3. And then we simplify. So y equals, use your calculator, okay? 2 squared, that's 2 times 2, 4. Okay, minus 4 times 2, minus 8, plus 3. Okay, order of operations, I'm going to subtract. So I get negative 4 plus 3, and y equals negative 1. Okay, so my vertex, the x was right here, x equals 2. The y is negative 1. So vertex 2 comma negative 1. Okay, let's look back at that picture and see how that looks. This part, we talked right before the trimester ended about the zero product property. So for the x-intercepts, we would factor. Okay, I'm going to show that in a different example. So let's take a look. All right, here. So let's think about all those pieces that we have. Okay, so line of symmetry first, LOS. That's like the first thing you can always find. All right, remember we take negative b over 2a. Okay, what's our a? What's that number in front of the x squared? A is negative 1, and our b is 3. All right, so negative b, negative 3 over 2a is negative 1. Okay, so it looks like we have negative 3 over negative 2. We can do that on our calculator, but that's going to be 1.5. That's fine. Line of symmetry, x equals 1.5. No big deal. Okay, some other things we need to think about. The vertex, does it open up or open down? Is it a minimum or maximum? So vertex, oh, sorry, that doesn't keep appearing. The vertex, so our a is negative 1, so it's a maximum vertex because a was a negative value. There's a negative in front of that. Okay, so remember we can take the x of 1.5 and put it in the equation. So y equals negative 1.5 squared. Notice, got the negative out front, the 1.5 is being squared, plus 3 times 1.5. All right, evaluate that on your calculator. All right, so we've got negative 2.25 plus 4.5. Okay, so y equals 2.25. Okay, so that's our y-intercept or y-coordinate for the vertex. So the vertex is 1.5 comma 2.25. All right, so right now we can plot this information on the graph. We know the line of symmetry is 1.5. So that's going to go through right through here, as close to that as possible. Okay, so there's x equals 1.5, line of symmetry. Okay, here's this point, 1.5, 2.25. I'm going to put that in blue, but it's a little bit above 2. Not that far above. And I'm going to make it a little bit bigger so we can see it a little bit better. So it's a little bit above 2, right about there. Okay, close enough. Next up, we can talk about the x-intercepts. So to do this, we're going to set y equal to 0. 0 equals negative x squared plus 3x. Okay, this is where we have to factor and set parts equal to 0. So what can we factor out? Well, 0 equals, I'm going to take out negative x. So I'm left with x minus 3. Anytime there's a negative, you should take that out. Okay, you should factor out the negative. Okay, so set both parts, 1, 2, set those equal to 0 and solve. So if we have 0 equals negative x, well then x equals 0 is one of our intercepts. And then 0 equals x minus 3. Okay, we'll add 3. And, sorry, x equals 3. So there's our two x-intercepts. I'm going to write them as ordered pairs. Oh, gosh. As ordered pairs. So 0, 0, and 3, 0. Okay, so I'm going to put those on a little bit bigger. So 0, 0, that's right here. Boom. And 3, 0. Okay, now things you should wonder, does that line of symmetry look to be in between them? If it does, then we're in good shape, and it does. So then you can make your graph right around that. We know it's U-shaped. We know it opens down because that's the vertex is a maximum. Okay. All of this, lots to think about. Looking on, I have this one for you. What I'm going to tell you is line of symmetry should be pretty easy, but to factor later on, okay, for the x-intercepts. First, factor out negative 2. So imagine this is y equals negative 2 times x squared plus 6x plus 8. Now it should be a lot easier to factor and solve for those x-intercepts. All right, give this one a try. See what you can come up with, and make sure you write down questions or where you're getting stuck. Thanks very much.